let's go back and explore inverse functions and talk about it in a little bit more detail. So why did we talk about one-to-one functions? You may be asking, what does that have to do with anything? Well, one-to-one functions are the only types of functions that are allowed to have inverse functions. So essentially, if someone asks you, does this equation have an inverse, you'd have to check to see if it was one-to-one. If it is one-to-one, we're going to go ahead and have an inverse. So just to recall, we talked about this a couple weeks ago, an inverse function basically reverses another function. So that is to say, if we're mapping x to y in one function, the inverse is going to take the y value and then map it back to x. So we're going backwards. And the notation for the inverse function is just the function name. So here it would be f, and then you have this -1 exponent, which indicates an inverse. And another fun fact about inverse functions, just in case you didn't know, is they actually reflect across the x equals y line. So if you wanted to, you could graph your functions and make sure they're a reflection across the x equals y line. Now, something we want to do with functions is we want to be able to find the inverse. Of course, you always want to double check that it is one-to-one first before you go and solve for your inverse function. And we talked about that in the last video. So if you don't know how to do that, always go back and check. But essentially what you do, if you have a one-to-one function, you take your x and your y value and you just flip them in the equation. Then you're going to go ahead and solve for y. So you're going to move everything to the other side, and you're going to replace that y value with f inverse of x. And that will be your inverse function. So let's go ahead and do that with these. Now keep in mind, f of x is the same thing as saying y. So what we're going to do is, this is really y equals 2x plus 5. To find the inverse, the first step is just to flip that y and that x. So it becomes x equals 2 times y plus 5. And then you're going to want to isolate the y, or solve for y. So first step is to subtract 5. Boom. X minus 5 equals 2y. Divide both sides by 2. Be cautious here because we want to divide both of these items by 2. So this would be x over 2 minus 5 halves. Make sure you're always dividing both of those terms. And the last step is to change that y to f inverse of x. And then just rewrite it as x divided by 2 minus 5 halves. Okay, let's try that again with our other example. F of x equals the quantity x minus 2 cubed. Again, we're just going to go ahead and switch that y and that x. So this becomes x equals y minus 2. This does not look like a 2. Okay, let's go ahead and rewrite that. X minus 2 cubed. Now we need to go ahead and solve for y. So the first thing, we need to get rid of those parentheses. If there's a cube in the way, the only way to undo a cube is to do the cubed root. That's what I heard you all say in my mind. Okay, great. So we're going to cube root each side, because roots and exponents are inverses of one another, so they cancel each other out. So you're left with the cubed root of x and y minus 2 on the right. Now we still want to isolate that y, so we need to add 2 to both sides. Now I'm going to do something a little tricky here. It's not really tricky, it's just a way to let me know that this 2 does not belong underneath that cubed root. It doesn't belong underneath there because there's no cubed root on that, right? Okay, so it's going to go on the outside, so I'm going to actually put the plus 2 in front and the cubed root of x in the back, just so I know that the 2 does not belong underneath there. It's easy to mistake those. Okay, so now last step, just change that to f inverse of x. 2 plus cubed root of x, and you are done. Boom, there's your inverse. Now, it's great to be able to find the inverse, but we also want to be able to check that two functions are inverses of one another. How do we do that? Well, the idea is that if you take one function and plug it into the other function and then simplify, you should simply get down to x. So you're putting one function into another, solving, and if your final answer is x, just by itself, just x by itself, that means the two are inverses. Now, if you get any other value besides x, x plus 1, 5x, whatever that is, that would indicate that these are not inverse functions. Or perhaps maybe I'm a little wrong, so double check your work, right? Okay, so we have two functions here, and we want to check that they're inverses. So what we need to do is we need to plug one into the other. It doesn't matter which one you plug into which, you should get the same result, and in fact, you could do it both ways to double check. So what I'm going to do is I'm going to take f of x and plug it into g of x. So I'm just going to replace x with my function f. So this would become cubed root, of x cubed minus 1, that was my f of x, plus 1. I'm just copying what's underneath. Now we don't need those parentheses, they're not going to make a difference, and so we can simplify. So bring together your constants under there, so cubed root, -1 plus 1 cancel each other out, you get 0 when you add those together. And then a cubed root and a cube actually cancel each other as well. So you are just left with x. So these two are inverses of one another. And in fact, you could have done it the other way. You could have taken g of x and plugged it in for x, and you would come up with the same thing where it would just be equals x in the end as well, as long as you follow those algebraic rules of simplifying. So that is how to check if two are inverses of one another. Give it a go. Try it on your own. See if you can take g of x, plug it into f of x, and get the same exact result. It's a good double check for yourself.